recording is a good thing. 3 sections today, 10, 11, and 12, all dealing with conversions. Going to need some feedback as we go. If there's a question and you think that we should go faster, feel free to verbalize that. I don't want to waste your time. These 3 sections can take a while. So it might seem like I'm rushing. Feel free to tell me to slow down. Feel free to tell me to speed up. You give me kind of the direction. So there's 4 of you in here today, which is a good group. So we'll kind of go at the speed you want to go. So what's due this week? Well, we've got our 3 sections in web work. And again, they're all conversions. Some questions are going to be easier than others. We call it a report. I don't want to say that it's Excel, because you do not have to use Excel. You have to create a table, and you can do that in 100 different ways. But it's a dosage calculations, and we will do a problem like that by hand today. And then you can kind of see, we'll talk about that assignment when we get to that problem. We've got a quiz, a discussion board. We are going to kind of talk about Project 2, because Project 2 goes along with Section 12. And it seems fitting that tomorrow is Project 1 is due tomorrow. So it seems, finish one, start the next one. I do have a video that kind of maybe will help you get started on Project 2. So I'm writing myself a note right now. So I will be posting that in the announcements. So when I post the recording of this live session, I will also post that Project 2 video, which might help you if you have trouble getting started. It might be just good to kind of give you an idea of what's going on. So are there any questions from any of you regarding anything before we get started? Exam 1 is over, right? That was due on Saturday. Those are graded. That might be my quickest turnaround ever for online exams, but they're all graded. Grades are in, so you can kind of see how you did. If you have any questions on those, please do just shoot me an email, let me know, and we can go from there. I will be monitoring the chat box, so feel free to type in the chat box as normal, or go ahead and unmute yourself and talk anytime you would like. So, all right, so nothing from you guys as of right now, no questions. So let's go ahead and just jump in. We are going to get, I need to fix this typo every time. This should say identity ratios, not identify. You will need your formula sheet. So in page 245 of your packet or your book, whatever you want to call it, is a yellow sheet. The front page of that, page 245, is what we're going to use today. And then next week, we will flip it over and use the other side. So hopefully you have page 245 out. And we're going to do conversions. Section 10 is all about conversions. 3 different sections. So the first thing that we're going to talk about with US Customary, we're going to need to talk about identity ratios. And identity ratios are simply ratio, right, which is a fraction, where the top and the bottom, the numerator and the denominator, mean the same thing. So if you think about that, 3 feet is the same as 1 yard. So we would call this an identity ratio. Every identity ratio can be written 2 ways, right? You can flip it, because 1 yard is the same as 3 feet. So depending on which one you want to use, will depend on what you start with. So you will hear me say a lot today, let the problem guide you, or let the labels guide you, because you really want to make sure that you're writing the labels down when you're using these identity ratios. So on page 245 at the top, you see a section called US Customary Units. That's the section we're going to start with. Each of those, one piece equaling another piece, can be written as identity ratios. Feel free to stop me if you have any questions, but we are going to get into our problems. My pedometer said I walked 11,520 feet yesterday. How many miles is this? All right, so when we're doing conversions, and I understand that some of these conversions you're going to be able to do off the top of your head, but I really want to focus on doing some, I would call this an easier problem, doing this with the steps. So generally we start with what we're given, and in this case we're given 11,520 feet. we're going to put that over 1 because when we're using ratios, ratios are fractions. We want to make sure that we can continue with our fractions. Now, think about when you multiply fractions. If you want to reduce, we reduce numerator to denominator. So feet would cancel out with feet. Just thinking labels. That means I want to make sure the labels are in a position to cancel out. Looking at my yellow sheet, I can see that 5,280 feet leads me to 1 mile. And so that yellow piece would be our identity ratio because the top and the bottom are equivalent. That causes my feet to cancel out, and now my label is miles. Now, because this number is in the denominator, right? When you're talking about multiplying fractions, if the numbers are both in the numerator, you would just multiply straight across. But this number is in the denominator, so we're going to take 11,520 and we're going to divide by 5,280. So, how many miles is this? Let's go to 2 decimal places. Can you guys hear me? Will somebody put something in the chat box so I know that you're out there? Thank you, Trent. You're alive. 5,280. If you look at the top of your yellow sheet, page 245, on the very, very left-hand side, you see length. Then it says 1 mile equals 5,280 feet. So because I started with feet and I want to go to miles, that's the conversion piece I needed to use. So I got it from the top of page 245, the yellow sheet that is a part of your book. And yep, there it is. Yeah, so this yellow sheet, the exact same paper, you will be given when you go to take exams 2 and 3. So this is your formula sheet, and so you know exactly what you're going to have when it comes to test day. Yeah, there we go, Kara, thank you. So 2.18 miles. Blue is not the best color, but it works for now. Okay, so you can kind of see the process. And we always want to start with the labels because we need our labels to cancel out as we move through the problems. And so we're going to try to do a good variety of these problems so you can kind of see how the different conversions on the paper work. But you know, as Trent just did, ask if you don't know where something comes from, and we'll talk about it. All right, so let's go to this next problem. I bought a gallon jug of juice. How many cups is this? So a gallon, refers to 1. We always start with what we're given, and I'm given 1 gallon. Well, now we're dealing with liquids. Liquid is volume, and on that yellow sheet in the top, volume is in the middle. So you see volume, I have gallons. The only thing I can turn gallons to is quarts. So if I look at that's the very bottom one in that section, I know that 1 gallon is 4 quarts. So you can see I chose to put gallons on the bottom because I need my labels to cancel out. And now the label that I'm currently in is quarts. Well, quarts is not what we want. We want cups. So I continue to look at my yellow sheet and I see that 1 quart is 2 pints. Right? Just using the next identity ratio. And this is where it really makes sense that you have to let the labels guide you because I need to cancel out the labels as I go. So that yellow step, 2 pints to 1 quart, allows my quarts to go away. Now I'm in pints. Well, I don't want to be in pints. So now pints are in the top. To get rid of them, I'll put pints in the bottom. And I know that 1 pint is 2 cups. So that orange step makes my pints go away. Now my label is cups. Cups is what I want. So now I can go ahead and do the math, if you will. So once you kind of have the steps in place, then you can do the math. All of our non-zero numbers, so we start with 1 times 4 times 2 times 2. Everything's in the top, so everything gets multiplied. How many cups is a gallon jug of juice? 16. Exactly. So your answer is 16 cups. Okay. So this is the process, right? Let the label guide you step by step, one at a time. All right, I want you guys to try this one. I bought a 17.3 pound turkey. How many ounces is this? So now we're talking about weight. You'll use the third box in that US Customary. So you can either say yes in the chat box or type your answer in the chat box, whatever you would like. Or if you get stuck, feel free to say that too. Okay, so Care's got it. Remember, you're starting with what you have. Christian's got it. Okay. So if we want to get rid of pounds, I always lead with my labels. So pounds have to go on the bottom. I know from that third section that 1 pound is 16 ounces. So that makes my pounds go away. How many ounces is this turkey? $278.8. I have 276.8. I might have a typo there, which is fine. Yep, good. So there's the process of US Customary, right? That's the first part of section 10. Okay, using that part and becoming familiar with that part of the page. Then we go to metrics. Now you can use identity ratio for metric conversions, but I think it's a whole lot more confusing because last time I checked, all of you can count to 6. And if you can count to 6, you can convert in metrics. So this is how it works. The unit in the middle here, where's my pen? This is like liters, grams, and meters. As you go, you have decimeters, centimeters, millimeters, right? Or decaliters, hectoliters, kiloliters. So all of these on the sides, the 6 on the side, these are prefixes, but they all, are in front of either grams, meters, or liters. The metric unit works in powers of 10, just like scientific notation, which is why we can count going to the left and right. So let's go ahead and count. Let me show you how this works. So we're going to change 380 centimeters to hectometers. So, and you can see this is the next box down on page 245. I'm starting in centimeters. Centa is here. So I put an X where I'm going to start, or your finger, whatever you want to do, and I want to go to hectometers. So, well, hecta is to the left. So I know that I'm going to move left. Okay, I start on the X. 1, 2, 3, 4 units. So I'm going to move left 4 units to get my answer. And you might say, that's a 2. You might say, I don't know what you mean by units. Well, think decimal points. Just like we did with scientific notation. If you don't see it, it's at the end. I'm going to move my decimal left 4. 1, 2, 3, 4. The empty hump gives me a 0. So my answer is 0.038 hectometers. So much easier to count than to set up a problem. You just have to recognize which way you're going, left to right, and you don't have to memorize these orders. It's on your yellow page, right? So that's the nice thing. All right, let's see if you guys can count, if that makes sense. Try this one, kiloliters to deciliters. Give me a yes when you have an answer, or a no if you get stuck. Okay, CARES got it. Okay, let's look at this. If you're using the count method, starting in kiloliters, which is the K, going to just D, not DA, just D, so that one's over here. So I'm going to move to the right, 1, 2, 3. This one goes right 4. So if I start with 4.5, you see the decimal in this one. So right 4, 1, 2, 3, 4. So in my 3 humps come zeros, and I have 45,000 deciliters. That's a comma. Okay. All right, let's try one more. Go 5 grams to centigrams. I'll give you a minute or so. All right. So let's look at this one. We're starting in grams. Now remember, grams is that central unit. So we're starting at the unit, going to centa. Well, I have to move to the right to get to centa. 1, 2. Right 2 places. So 5 grams, decimal points at the end. Move it right 2. That leaves me with 500 centigrams. Okay. Questions about the metric conversions? Or any conversions so far, I guess. Okay, then we're going to, what I call, jump across the pond. So we have US metric, or US, and we have the metric. So I always think the US, and then I always think, you know, there's the big ocean in the middle, and then we have Europe, and Europe uses the metric system. So I always say, when you cross between the US and the metric system, I always say jump across the pond. You watch any of my videos, that's how I'm going to reference it. So the third box down on that sheet is the conversion between US and metric. Now these are approximations. You will notice on that sheet there's not equal signs between these. There's squiggly lines, and the squiggly lines are approximations. So you want to make sure that you're using things on this sheet, because there are other conversions that you can Google that work for this. But if you don't use the ones on the sheet, you're going to be slightly off on the answers in WebWork, and it's going to count you wrong. So make sure you're using this conversion sheet to do your homework and your exam. Okay, so jumping across the pond. Some of these I call easy, And the easy problems, I say they're easy because they're one step. One-step problems are always easier than multi-step problems. That's, basic. So this would be an easy problem. I weigh 170 pounds. Okay, so 170. What is that in kilograms? Well, if you look at the third place down, you know that pounds and kilograms, right? This is US and this is metric. Well, luckily, if you look back, pounds go to kilograms. You can see that in the third, it's weight, so it's the third box over. So I can see, let me change colors for effect. I can see that 1 pound is 0.4536 kilograms. And I apologize, if you work in the medical field, you use 2.2 pounds as a kilogram. Yeah, that's an approximation, but your answer is going to be slightly different, and WebWork will count you wrong. So please just use what's on this sheet to make your life and mine a little bit easier. Okay, so pounds cancel out. I'm left with kilograms. So I just take 170 and I multiply by 0.4536. And if you weigh 170 pounds, what is your weight in kilograms? $77.11. Very good. Kilograms. So that's the process of jumping across the pond. Sometimes they're more detailed than others. Some they're one-steppers. So it kind of depends. So let's do a more difficult one, or at least one that has more steps. So 16 ounces is how many milliliters? We're talking liquid. Okay. Well, if you look in the middle for volume, right? Because we know, ounces is US, milliliters is metric. I have to jump across the pond. But with volume, the only way to jump is to take 1 quart equals 0.9464 liters. Quarts to liters. Well, I don't have quarts. I have ounces. So for this particular problem, you're going to have multiple steps, right? You're going to start with 16 ounces. And our first step is to say, okay, I need to take these ounces and turn them into quarts, because quarts will allow me to jump across to the metrics. Then I can deal with metrics when I get there. So your first kind of thought process is, how do I go from ounces to quarts? Well, if you look at your US Customary top box, ounces go to cups. So 8 ounces is 1 cup. And this is a step-by-step process, right? So that makes your ounces go away. Now I'm in cups. Well, I don't want to be in cups. I need to be in quarts. So I know that 2 cups is 1 pint. Well, that's great because it gets rid of my cups. But again, now I'm in pints. I still don't want pints. I want quarts. So now I know 2 pints is 1 quart. Finally, I'm where I want to be. Pints go away. My label is quarts. Now I can use my jump across the pond, because I know that 1 quart is 0.9464 liters. And this is a pretty involved problem, right? Look at all the steps that we have. Now, I don't want liters, I want milliliters. But when I do metrics, I count, right? I need a number and I need to be able to count and move the decimal. So before we count, I need to get an answer. So I start with, okay, I have 16. I'm going to divide by 8. I'm going to divide by 2, and times 0.9464. Notice what I did here. Anything in the denominator, the 8, the 2, those are all being divided by, and I'm multiplying by the number in the top, which is the 0.9464. So when I do that, I should end up with 0.4732 liters. Okay. And that's great. Liters are great. We love liters. I'm not disrespecting liters, but that's not what I want. I want milliliters. So riddle me this. If I want to go from liters to milliliters, which direction and how many am I moving? From what we just did a little bit ago in the metrics. Liters to milliliters. Which direction and by how many? right? 3, exactly. So I take my decimal, 1, 2, 3, and I end up with 473.2 milliliters. And that, what I would consider that the most difficult problem that you would encounter in section 10, because you've got to do conversions in both US and metric and jump across the pond. That's kind of the entire section is one. All right, but that's section 10, and there you go. Section 11, we get into temperature. Now, if you look down, this is the 4th box down. We can go both directions, and it depends on what you start with of what you want. So we want to go to Celsius. That means I want to use the formula that has the C by itself. 5/9 times F minus 32. You'll notice that only one of these formulas has parentheses. Do not add them in the other one, right? Parentheses only belong here. And to change formulas, right, this is just kind of a plug and chug type deal. So we have 72 Fahrenheit, so we plug that in for F. So 5/9 times 72 minus 32. Hopefully the order of operations has not left you from your younger days, right? We always want to start in parentheses. So 72 minus 32 gives me a nice, beautiful number of 40. And then once you get to this green step here, remember the fraction bar is a division bar. So this is just saying 5 divided by 9 times 40. And you can do that in your calculator all at the same time. And depending on what you round to, we would end up with 22, whoops, I should go this way, 0.2 degrees Celsius. Okay. And I know I didn't really ask any questions. I just kind of went through that kind of quickly. But it's already 2:26 and we're just starting section 11. So I don't want to rush too much, but I also don't want you to be here till 4 o'clock because class is only an hour long. So if I'm going too fast through any of these problems, just tell me to slow down or ask me some questions. But some of these things, I think once you kind of see them, they shouldn't be hopefully too bad for you. Now you'll see in this problem, we have Celsius, we want Fahrenheit. So that means we want the F to be by itself. So we're going to use the other formula, 9/5 times C plus 32. And again, this is an order of operations problem. So as long as you have that in the back of your head, it won't be too bad. Knowing Celsius is 4. So I'm taking 9/5. If they're touching, that means multiplication, plus 32. Order of operations says you always add last. So this chunk I'm going to do first, 9 divided by 5 times 4, which leads me to an answer of 7.2. Then I add 32. So 4 degrees Celsius is the same as 39.2 degrees Fahrenheit. And so those, the more you do, the easier they get. Just becoming familiar with the formulas is really kind of the key to those problems. So, any questions on temperature, Celsius, Fahrenheit, anything there? Oh, good. No, look, yeah. Hey, still responding. I appreciate that. You never really know when you're talking to a computer. Okay, the rest of section 11 is more conversions. Some of it we will use the pieces from up top that we used in section 10. And some of it we will use the special conversions and the other useful information at the bottom of page 245. So things to remember. Area is square units, right? We might say it's feet squared or inches squared or yards squared. And that's because when you're talking area, like you're carpeting a room. Well, if your room is a rectangle and you want to find out how much carpet, you're talking about square feet. If I put this into little squares, whoops, how many square feet would fill up this room? Okay, volume is cubic units. So like feet cubed, inches cubed, yards cubed. They're three-dimensional because volume is like a tissue box that we got to fill up. So you're talking about a three-dimensional shape that has a length, a width, and a height, whereas our area only had length and a width. So volume might be, I want to fill up my room with jelly beans and see how many jelly beans it would take to cover from floor to ceiling, right? It's three-dimensional. which is why we have the units. The exponent of the unit will tell you how many times you need to use your conversion, because feet squared is the same as feet times feet. So you have two labels. That's why it's squared, right? 2, and that's why you have to use your conversion twice. All right, let's do one of these. Let's stop talking and let's do. So first off, what is the area of a sheet of paper in square feet? Now, I do this problem because you have a problem very similar in your homework where it talks about a sheet of paper. Well, friends, if you don't know the dimensions of a sheet of paper, you can't do the problem. So, first of all, do you know the dimensions of a sheet of paper? Eight and a half by 11. Yep, and it might be helpful to even say inches. So a sheet of paper is 8.5 by 11 inches. So when we want to find the area, remember, so a piece of paper is a rectangle. It's 8.5 by 11, and again, these are inches. How do you find the area of a rectangle? Length times width. So just like I have written up here, right, 8.5 inches times 11 inches. Well, if I multiply those two together, I end up with an area of 93.5 inches squared. And it's inches squared, notice, because I have inches times inches. Well, that's all great. I found the area. I did fabulous math, but that doesn't answer the question. The question says square feet. So if I take my 93.5 square inches, I want to change those square inches to square feet. Well, remember, square inches means inches times inches. There are 2 of them. So I'm going to take my 12 inches is 1 foot, and I'm going to do it twice, because we have inches times inches that make up inches squared. So inches times inches makes up inches squared. And now my label is feet squared. So I'm going to take 93.5 and I'm going to divide it by 12. And then I'm going to divide it by 12. And what is the area of a sheet of paper in square feet? Very good. So 0.65 feet squared. So you can take what we did technically in section 10, put it on steroids, and we have ourselves more conversions. Just remember, whatever your exponent is, that's how many times you have to do your conversions. Okay. Let's talk about volume. A bag is 18 inches by 16 inches by 2 feet. What is the volume in cubic inches? What do you have to do first here? Because this is not a simple one-step problem, right? We've got a couple different steps to do. But what do we have to do first here? If we want to find the volume in cubic inches. Does anybody notice anything? Exactly, Kara. You've got to change those feet to inches. When we're finding volume in cubic inches, that's inches times inches times inches. So our first step is to say, well, these 2 feet are how many inches? Well, if you think about the process, I know that 1 foot is 12 inches. So 2 times 12 is 24 inches. So now I can find the volume. Volume of a rectangular piece, rectangular bag, if you will, is length times width times height. And we know they all have to be in the same units, inches times inches times inches, because I want cubic inches. So if I multiply those three pieces together, 18 times 16 times 24 gives me how many cubic inches? Excellent. So 6,912 cubic inches. So that's the first part. Then it says, what about cubic feet? Well, no problem. I know how many inches are in a foot, so I would just take 12 inches is 1 foot. How many times do I need this conversion, this identity ratio? 3 times. Yep, there's 3 inches, so I need 3 labels of inches in the denominator. So 1 foot is 12 inches, 1 foot is 12 inches, 1 foot is 12 inches. So that allows me to say 1 inch, 2 inch, 3 inch cancels out with 3 inches. I'm going to take my 6912, forgot my 9. I'm going to divide by 12, divide by 12, divide by 12, because they're all in the denominator as they should be. And how many cubic feet do we have? 4. Exactly. So 4 cubic feet. Okay. How we doing? Everybody doing okay? All right. Now, I do want to say there's not one way to do this. You know, we found cubic inches first and then we changed it to cubic feet. If you wanted to, you could change each of these to feet, 18 inches and 6 inches to feet, and then multiply those 3 together to get cubic feet. So you do have other options. It's not all, you know, step by step exactly the way we're doing it here. You have options. Just kind of want to throw that out there. Okay. Kara's doing a great job responding. I hope everybody is okay. The rest of you are just taking it all in, which is fine. Nothing wrong with that. Make sure you interrupt me if you have questions. A soup can is 5 inches tall with a radius of 2 inches. What is the volume in cubic centimeters? So just like I talked about earlier, you have 2 ways to do this problem. You can first change your inches to centimeters, or you can find the volume in cubic inches and then change it to centimeters. It doesn't matter. Does anybody have a preference of which way we do this problem? Do you want to change it first, or do you want to find the volume first? Change or volume? Okay, seems nobody has a preference, or people are writing down the problem and just not ready yet. We're going to find the volume first then, because I think that sometimes that's what people see. They see what is the volume, so that's what they do first. So a soup can, if you can picture a soup can, is cylindrical in shape. So it's 5 inches tall and has a radius of 2. So hopefully you remember that when we're talking about a circle, the radius is from the middle to the edge. So that's the radius. And if they're talking about the diameter is all the way across, cutting through the middle. So the radius is 1/2 of the diameter, just for future reference. Now, finding the volume of a cylindrical object, volume is pi times r squared times the height. And remember that r squared, that's the radius squared. So this is really saying that we have the radius times the height. This is why our label is going to be cubed, because we have 3, in this case we're dealing with inches. Radius is in inches, radius is in inches, height is in inches. So 3 of them, that's why we will have cubic units. Okay, so in this problem, I have pi, my radius is 2, I'm going to square that, and my height is 5. Now, your calculator may or may not have the pi button, and it's okay if it doesn't. The web work is set up that it will take 3.14, which is the decimal approximation for pi. Remember that 2 squared simply means 2 times 2, and then we're multiplying by 5. I don't know if I used the pi button or if I used 3.14, so I'm going to do this in my calculator real quick. All right, so if you use 3.14, you end up with approximately 62.8 inches cubed. And that is the volume of this soup can, cubic inches. So thinking about like just a little cube, maybe like a dice is generally a cube. If they were an inch on each side, you could fit 62.8 of these in this soup can. That's what this means, right? Filling it up. But the question says cubic centimeters, so I'm going to have to jump across the pond. And luckily enough, inches and centimeters convert nicely. So, where's my paper? 1 inch is 2.54 centimeters. And my exponent is 3, right? So I'm going to do this 3 times. Should make sense. Cubic centimeters are smaller than cubic inches. So you will have quite a bit more cubic centimeters fitting in this can. So 1 inch, 2 inch, 3 inch cancels out with 3 inches. I multiply all the way across. When you're done multiplying, what do you get with all of that? Excellent. 1,029.11 cubic centimeters. And there you go. So part of it is the formulas, which those are given at the very, very bottom of that, page 245. You'll see other useful information. The special conversions right above that, we're not going to do any of those here in this particular live session. They are in the videos, so feel free to watch the videos to get those special pieces. I want to fast forward now to rates. And rates, it's nothing we haven't already done, but it takes you to go back to, I think it's section 7 when we do like per capita. Remember that per means fraction bar. So when I read this problem, I ran 5.3 miles per hour. Well, 5.3 miles per means division bar, and then I have 1 hour. I have a rate. I now have labels in the top and the bottom. And this isn't a problem, right? We know how to cancel out labels. It doesn't matter where they start. But you'll see at the end, we want this in meters per second. So meters per second. This is what we want to have happen. So I need to change the top and the bottom. Okay. Now, first looking at this, I see hours. I know how to go from hours to seconds. That's what I want to do first. It doesn't matter what you start with because you're going to change the top and you're going to change the bottom. Order doesn't matter. So I know that 1 hour is 60 minutes. And so you notice that I put hours in the top because I need my labels to cancel out. So if I have hours in the bottom here, hours in the top in the next will cancel out. And now my label in the denominator is minutes. And while minutes are fabulous, that's not what we want. And I know that 1 minute is 60 seconds. Now you'll notice the time conversions are not on your yellow sheet. You are expected to know the time conversions. So 1 minute to 60 seconds makes my minutes go away. And then you'll notice my label is seconds. That's what I want. So my denominator is officially in the label that I want it to be in. So now I need to change the top, right? I got to go from miles to meters. Well, hopefully you recognize miles is US, meters is metric. So I have to jump across the pond. And if I look at that conversion between US customary and metric, the third box down, I see that miles goes to kilometers. So I can say, okay, I know that 1 mile is 1.6093 kilometers. Now, you might know how many meters are in kilometers, so you might be able to do another conversion. But I know that in my head for metric, I count, right? I move decimal places. So I'm going to get myself a number. At this point, I feel good. I'm in kilometers per second because the miles canceled out. So I take 5.3, I divide by 60, and then I divide by 60 again. Then I multiply by 1.6093. Again, numbers in the denominator you divide, numbers in the numerator you multiply. And that should take you to a small number, 0.00237. I'm going to round, and that's kilometers per second. Okay, recall back from that metrics. If I want to go from kilometers to meters, right, so kilometers to meters, I'm going to go right 3 places. So I take my decimal where it's at, 1, 2, 3, and that takes me to 2.37 meters per every 1 second. So 2.37 meters per second would be the conversion for that one. Again, I would say that that is a harder problem because it's got all kinds of stuff. It's got top and bottom, US and metric. I always feel like you should get the harder problems here. That way when you go to do your homework, they seem easier. That's kind of the goal, if you will. Okay, any questions about section 10 or 11? Oh, crap, I didn't get to the dosages yet. Man, either I'm talking slow or, yep, we'll go with that. Okay, so problem 18 here. This is what your dosage error assignment, the report piece, this is what it's about. In a nutshell, that assignment, basically, you're going to be given a list of patients, their gender, their weight, and how much of a particular drug they were given. And you have to decide if they were given an appropriate dose or if they were overdosed or underdosed. Right? So was it good? Was it close? Or and then you have to figure out why. Well, try to figure out why. You know, do you see any patterns? What kind of math mistake was made? If a math mistake was made, that kind of thing. And this is the process. And you can do it all by hand, or you can do it in Excel. It's up to you entirely. There is no, you don't get bonus points for using Excel, and you are not punished for doing it by hand. It's simply whatever you want to do. So here's the deal. Steve weighs 188 pounds. His drug dosage is 25 milligrams per kilogram to be given twice a day. How much is in each dose? Okay, so hopefully you recognize the problem is that Steve is weighed in pounds, but the drugs are administered in kilograms. And this is a very true statement. Most drugs are manufactured in metric units. And so there has to be these conversions to go back and forth between US customaries. So our first job is to get Steve into the metric unit of system. So we want to take his 188 pounds and change it to kilograms. And, you know, recall pounds to kilograms, we're jumping across the pond, but this is an easy one-stepper. So we know that 1 pound is 0.4536 kilograms. So that first step gets us out of US and into metric, which is good. That's what we want. However, we're not really concerned with how much he weighs. Nobody really cares how much Steve weighs. We care about how many drugs we're giving him. So now we know his drug is 25 milligram per kilogram. That's a rate, right? Per is the division bar. So the 1 kilogram will go in the denominator, and the 25 milligrams goes in the top. And again, this is let your labels guide you, right? We want to get rid of the kilograms. They cancel out top to bottom. Now, this answer right here will give us total milligrams for the day. So when I multiply across on the top, the 188 times the 0.4536 times the 25 milligrams, I get a total of 2131.92 milligrams. But that's the total for the day. If you put that into this guy's IV all at one time, you're going to shock him and maybe kill him, right? Because it's to be given twice a day. So what do I do with that number to make it an appropriate dose? Divide by 2. Exactly. So divide that by 2, and we would say, I'm going to round to the nearest milligram just for fun, 1066 milligrams per dose. So this is what you're going to figure out in that dosage assignment. What should have been the appropriate dose and comparing to what they actually got, and then making some, statements about that. Okay, so this is, you can refer to this. There is another one. If you watch the videos for the sections, there's another one of these in there, and we'll go with that. So, okay, that's section 11. We've got one more section to get to, which shouldn't be too bad. I need to switch PowerPoints. You know it's impressive when you got to switch PowerPoints. Okay. Swap that, move, boop, boop, boop. There we go. Section 12, carbon dioxide emissions. You will see the third box from the bottom on page 245. It says carbon dioxide emissions. We're going to use this from gasoline and from electricity. And it's not too bad. The thing about it is that if you read a problem and it says blah, 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 carbon dioxide or CO2, right? Carbon dioxide is known as CO2, and gasoline, you have to use 19.8 pounds per 1 gallon of gas. And that's because, and if you watch the video, it explains how this comes to be. But for every 1 gallon of gas you burn in your car, you create 19.8 pounds of carbon dioxide into the atmosphere, right? That's what you produce per gallon of gas. It makes me feel like a greenhouse killer when I drive my car, because I drive a lot, but you know what it is, what it is. So this is a conversion you have to use when talking about CO2 and gasoline. Now, when we talk about electricity, electricity uses less or produces less. Electricity produces 1.37 pounds of carbon dioxide for every 1 kilowatt hour, because kilowatt hours is how electricity is calculated. So you might think about light bulbs. Light bulbs, they tell you how many watts, right? It's a 40-watt light bulb. So we're going to have to change watts to kilowatts, multiply how many hours we're in, and then we will have kilowatt hours. So generally, people think that gasoline is the easiest to deal with, and I tend to agree. It's a little bit less work than electricity. We'll do a couple of each of these, and then we'll call it a day. But this section 12 is what project 2 is based off of. So you are going to need page 102, I believe, in your packet for your homework and for this exercise. That's what the electricity watts section comes from. But first, we're going to talk about gasoline. So just kind of a basic, I use 17 gallons of gas to get to work each week. How much CO2 do I produce? So some of these problems, I think some of these are easiest to work backwards. We're talking about gas, we're talking about CO2. As I mentioned, you have to use 19.8 pounds over 1 gallon. This is non-negotiable. If you're talking about gas and CO2, you have to use this. Well, we want to know how much CO2, so that means we want our final answer to just be in pounds. So I have to get rid of these gallons if you think about how to work backwards. Well, again, let the label guide you. If I want to get rid of gallons, they have to go in the numerator. Well, I use 17 gallons of gas. So 17 gallons over 1. That makes your gallons go away. Both of these numbers are in the numerator. I multiply just straight across, and I would produce 336.6 pounds of CO2 each week based off this problem. Okay. Again, I would call that an easy problem, right? It's one step and done. But that's kind of the general gist of gasoline. We're using that 19.8 pounds over 1 gallon of gas. Okay, let's do one that has a little bit more involved with gasoline. My car averages 37 miles per gallon. If I drive 400 miles each week to work, how much CO2 do I produce? So now this one has 2 pieces of information, but the question remains the same. How much CO2? So I'm still looking for a final answer in pounds. So my last step is going to be that 19.8 pounds over 1 gallon of gas. So sometimes these, if you're given, in this case, we're given 2 pieces of information, it's hard to know with which one do I start with, right? Because it depends on where you're at. But if you go backwards, I know that I have to have gallons in the numerator. And if you look at this, 400 miles is just miles, but this is miles per gallon, and per is the fraction bar. So I know that 37 miles will go on the bottom per 1 gallon of gas, right? Miles per gallon is a rate. It's got 2 units. That allows my gallons to go away, and now I still have miles on the bottom, which I don't want anything on the bottom. But now I can use my 400 miles. So if I have 400 miles to start with, so I can take my 400 divided by 37 times 19.8, and that would give me 214.05 pounds of CO2. Okay. Questions about CO2 and gasoline? The only way to really make those problems harder is to maybe start in liters. So you'd have to change liters to gallons first, a little bit more conversions. But just straight up CO2 with gasoline, you got to use that 19.8. If you got that in your head, those really aren't too bad. All right, let's switch to electricity. And this is where you might need that page 102 because that's where you get the watts. So I use my microwave 6 hours a month. How much CO2 do I produce in a month from just my microwave? Now remember, if I'm using electricity, hopefully you recognize this is not gasoline, this is electricity. I'm going to be using 1.37 pounds is 1 kilowatt hour. So I need to figure out how to get kilowatt hours in my numerator. That's kind of my key. So in looking at page 102, can any of you locate the microwave? How many watts is a microwave? Did anybody find that? $1,500. Exactly. Okay, so I know that the microwave is 1,500 watts. Well, think about the metric system, because basically watts, they're metric. So you have kilowatts, you have hectowatts, you have decawatts, you have watts in the middle. So we want kilowatts, not just watts. So using our metric system, if I start in watts to go to kilowatts, I'm simply going to go left 3. 1, 2, 3. And that gives me 1.5 kilowatts. Okay, that's one way to do it. The other way to do it is to think 1,500 watts and to think 1,000 watts is 1 kilowatt. I think this option 2 here in the bottom, if you watch my videos, I'm pretty sure that's how I do it. I think I use the conversion, but you can count just as easily, because if you take 1,500 and divide by 1,000, you get 1.5. So the mathematics is the same. It just depends on how you want to set it up. Okay, so if you like to count, move left 3, watts go to kilowatts, and then you can move on. Okay, so I have kilowatts. So those kilowatts will go with those kilowatts. That's good. But now I need hours. So how many hours do I use this? Just 6, right? That's what the problem gives us, 6 hours a month. So you can kind of see your goal for these problems is you want to have a kilowatt, you want to have an hour, because the kilowatts cancel out with kilowatts, the hours cancel out with hours, and now I'm left with pounds. So for my math, I take 1.5 times 6 times 1.37, and my microwave will produce 12.33 pounds of CO2 each month in terms of electricity. Okay. So those are the kind of the 3 pieces you're looking at: kilowatts, hours, and then the conversion to pounds. Just basically 3 steps. All right, let's do one more. My clothes dryer is used 3 hours a week. How much CO2 do I produce in a year? Okay, so think about the steps. We want a kilowatt steps, we want an hour, and then we want the conversion. Well, I know the conversion is 1.37 pounds over 1 kilowatt hour. If you look at page 102, how many watts does an electric clothes dryer use? $3,400. Okay, so if I have 3,400 watts, I'm going to take my decimal point and go left 3. So that gives me 3.4 kilowatts. Okay, now thinking about the number of hours. If we use it 3 hours a week, and we're talking about a whole year, how many weeks are in a year? Three hours in 1 week. There are 52 weeks in 1 year. So 3 times 52 gives me 156 hours. Right? And you could have that 3 times 52 in the problem. That's fine. I'm just trying to keep the problem clean, if you will. So that kilowatts cancels out with kilowatts, hours cancels out with hours, multiply straight across, and this gives me 726.648 pounds of CO2 in a year. It's 3 o'clock, so I want to kind of wind down. We did 2 of each. You'll notice on page 103 in your packet, they're what we call energy vampires. If you have things plugged in but they're not on, they're still drawing energy, but they're drawing less energy. So the wattages on that second page we would use as energy vampires. It is 3:01. We can call it done and be done today, or do you want me to talk a little bit through project 2? It's up to you guys entirely. I do have a small, video, but it doesn't necessarily talk about the details of it. What would you like? Project or done? Okay, Kara's got to go to work, so she's out. Is anybody else still listening? All right, well, I'm going to go ahead and talk about project 2 just real quick. If you have to leave, go ahead and leave. But you can always come back and watch the video at the hour mark, and that might allow you to see what's going on if you'd like later. Okay, so project 2 will be found under module 12. Well, it should be. Where the heck is that thing? Oh my goodness, I'm way too far. Okay, there it is. Project 2, CO2 conversions with section 12. All right, so the CO2 emissions project is all about carbon dioxide emissions. So you have, and I'll post the video that really goes through this, but you're creating 2 spreadsheets. The second spreadsheet is a copy of the first, and you're going to list 6 appliances that you use. So don't pick, your hair dryer if you never use your hair dryer. If you do laundry every day, then use a washer, use a dryer. You can use page 102 for your wattages. We're also going to use 4 energy vampires, and you can use the same appliance for both. So if you watch TV 6 hours a day, that means you don't watch TV 18 hours a day. So you can use the TV in 2 different spots. But notice that you need to use Excel formulas for all of these. And what you're going to do is you're going to figure out your CO2, how much CO2 you produce, and you're also going to talk your cost. So if it's 15 cents per kilowatt hour, well, how many kilowatt hours do you use? And you go from there. We're also going to talk about gasoline consumption. So what does it cost for you to use gasoline, and also in terms of CO2. for gasoline. For the cost of gasoline, you're going to use whatever it is the day that you're doing the project. So the last time you filled up, it might be different for everybody, and there's nothing wrong with that. We all, should be within, 20 cents or so, hopefully, but nothing big. So once you finish one spreadsheet, you will copy that into the second spreadsheet, and then you'll do you're going to reduce your CO2, and you'll go through this and read this, and that'll make more sense. And then, of course, you have your reflection paper that goes along with it. I recommend as you're doing your reduction strategy that you make notes, because when you write your paper, you're going to talk about your reduction strategy. And if you don't take notes as you're doing it, it's a whole lot harder to remember later what you actually did. So I do recommend starting this sooner rather than later. The third sheet is an organizational page. If you want to kind of start with what am I using, what's the wattage, and how much do I actually use those items, that's good. Here's your project checklist. I just want to make sure everything is in there and that you're using formulas. If you want me to check the Excel portion of this project, just like for project 1, I will. Just shoot me that in an email, and I would be happy to get that back to you. So I didn't go in too much detail, but where to find it, you do want to get started on that sooner rather than later. Reminder that project 1 is due tomorrow, and we'll go from there. So hopefully it wasn't too bad, but if you have questions, we did sections 10, 11, and 12 very quickly today. Not a ton of examples in any of the sections. So as you're working through that homework, some can be difficult. Just shoot me an email. It might be easiest if you attach a copy of your work if you send me an email, so that I can, help you to the best of my ability. So thanks. Have a great day. Have a great week. And next week we'll get some easier sections next week. We start off pretty difficult here in the beginning of this unit. So thanks for sticking around, and I'll see you next week.